All right, let's do a lesson on radicals. First of all, what's a radical? This right here, we've always called it a square root. It's technically a radical. And what's underneath the square root is called the radicand. Okay, radical, radicand. Our plan for this video, I'm going to go over some basic rules, which I need you to write down. We're going to do some basic simplification and some rationalizing. What does simplest form mean? This is important because when you guys get to the problems where it says put your radical in simplest form, what does that mean? First of all, there can be no perfect square factors in the radicand. So underneath the radical, everything under there, none of the factors that make up a number in here can be a perfect square. No fractions in the radicand. So in the radicand, you cannot have a fraction. Okay, and no radical signs in the denominator. Sorry, let me erase that line. No fraction signs in the denominator. Okay, so that's what simplest form means. This can be none of that, and none of that. Basic rules. First of all, the square root of AB equals the square root of A times the square root of B. You can go in this way too. Square root of 3 times the square root of 4 equals the square root of 3 times 4, which is 12. Okay, the square root of A over B, all underneath the radical, you can split that radical up into the square root of A over the square root of B. So if we have the square root of 81 over 9, it's the same as the square root of 81 over the square root of 9, which equals 9 over 3, which equals 3. You could also do the division here first. 81 divided by 9 is 9. Square root of 9 is 3. Next example, square root of A plus the square root of A equals 2 square roots of A. Example, 3 square roots of 4 plus 2 square roots of 4 equals 5 square roots of 4. In this instance, you almost treat this piece like a variable. If they have the same radicals, then you can add the coefficient, which in this case the coefficient is 1. So I have the same radical. So if I collect like terms, I would add 3 plus 2 is 5, and square root of 4 doesn't change. Same with subtraction. 3 square roots of A minus square root of A, coefficient's 1, is 2 square roots of A. Same if they're numbers. Oh, it was bad use of a perfect square here. Sorry. If we have 10 square roots of 3 minus 3 square roots of 3, you can actually, since these are like, you can do that subtraction, 7 square roots of 3. And when you have addition underneath the radical, you can actually add. More basic rules. When you have subtraction underneath the radical, you can subtract. 10 minus 3 is 7. Multiplication, 4 times the square root of A times 3 times the square root of B. You can multiply what's in front to get 4 times 3 is 12, and multiply what's underneath, which is AB. The last one, 3 times the square root of A, quantity squared. You distribute that square. So I would get 3 squared and the square root of A squared, which is 9A. Alright, first off, basic simplification. We need to know what perfect squares are. These are all perfect squares. And I could go on. Mean 11 squared is 121, etc. A perfect square is a number that when you take the square root of it, you get an integer. Okay, square root of 36 is 6. It's an integer, no decimals, nothing. Okay, that's a perfect square. We need to know what those are. Sometimes you can write those on the side of your paper, and it'll help you remember what your perfect squares are. Okay, basic simplification. I'm going to factor these numbers into perfect squares. 125. My factors are, let's see, 1 times 125, 2 doesn't work, 3 times, let me see. Okay, 3 doesn't work. And I can't erase that 3. 4 doesn't work. 5. Times 25. Hey, 25 is a perfect square. So underneath my radical, 125 is the same as 5 times 25. Okay, and you can keep breaking down your what's underneath your radical. We learned a rule that underneath the square root, 5 times 25 is the same as square root of 5 times the square root of 25. I can actually take the square root of 25 because it's a perfect square. So this right here becomes my 5. 5 square roots of 5 is the answer. Okay, let's try this in a different way. 45 breaks up into 1 times 45. 2 doesn't work. 3, I think, does work. 3 times 15, neither one of those are perfect squares. 4 doesn't work. 5 times 9, hey, 9's a perfect square. So we can break this up into 5 times 9. 5 is prime, can't factor it any further. 9 goes to 3 times 3. Okay, whenever you have matching numbers, you can take one out of the radical, and what's left over is a 5. Sometimes that works for some people. It helps understand. Okay, if I would have done that here, let's try square root of 125 again. 5 times 25, 5 times 5. When we get a matching pair, it can come out of the radical, and what is left over stays in. What's left over stays in. Basic simplification again, 75. Factors are 1 times 75, 2 doesn't work, 3 work. Yep, 3 times 25. Hey, 25 is a perfect square. Let's try that. 3 times 25. 25 breaks up into 5 times 5. Whenever we have a matching, it can come out of the radical, and what's left over stays underneath. Okay, 80. 1 times 80. 2 times 40. 3 doesn't work. 4 times 20. 4 is a perfect square, but let's keep going. 5 times 16. Okay, 5 is prime, 16 is a perfect square. So this 80 breaks up into 5 times 16. 16 is a perfect square, so I can actually take the square root. Square root of 16 is 4. And when I take it out of the radical, it becomes a multiplication problem times 5. 20 times 4 is, 5 times 4 is 20, so 20 square roots of 5. Notice I did these two problems differently. Here I'm factoring until I get a matching pair. Here I have a few shortcuts. Another basic simplification. Here I have a multiplication problem. Okay, you can do this two different ways. First, I can actually multiply. Negative 4, 3 times 24 is 72. And then I can factor. 72 is 2 times 36. Hey, 36 is a perfect square and 2 is prime. So I can factor this pretty simply. 2 times 36. I can take the square root of 36, which is 6. Negative 4 times 6. Square roots of 2. 4 times 6 is 24. and I am done. Or I can factor first, then multiply. 24 breaks up into 2 times 12, which doesn't help, 3 times 4, which does. Sorry, not 3 times 4. 2 times 12, 3 times 8 does not help. 4 times 6. There we go. Let me erase this. 4 times 6. I can take the square root of 4. 2 square roots of 6 times negative 4 square roots of 3. 4 times 2 is 8. 3 times 6 is 18. 18 breaks up into 9 times 2. Square root of 9 is 3. Negative 8 times 3 is negative 24. Square root's 2. Tad bit longer way to do it, but I did get the same answer. Okay, rationalization. If you remember the rule that said when things are simplified, they cannot have a radical in the denominator. So we need to get rid of that radical. And the best way to get rid of the radical is to make the denominator a perfect square. To make the denominator a perfect square, I need to multiply it by itself. So I'm going to multiply it by what's in the denominator, square root of 5. Now, in math, we've learned I can't just randomly multiply something by something else, but I can multiply it by 1. Okay, square root of 5 over the square root of 5 is the same as 1. So I'm multiplying 4 over the square root of 5 very creatively by 1. So when I multiply in math, I multiply across the top of the numerator and the top of the denominator. So that gives me 4 square roots of 5 over the square root of 5 times the square root of 5 is the square root of 25, which simplifies into 5. And I have my answer. So this next example, I'm going to multiply by 1, which in this case I'm going to make square root of 3 over the square root of 3. Multiply across the top, across the bottom. Square root of 5 times the square root of 3 over the square root of 3 times the square root of 3. Square root of 15 over square root of 9, which is over 3. Okay, 2 more. Now, in these next 2 examples, my denominator has a whole number and a radical. I still only want to get rid of this radical, so I'm going to multiply by 1, which in this case is going to be square root of 5 over the square root of 5 again. And that gives me, if I multiply across the top, across the bottom, square root of 15, which is 3 times 5, over 4 square roots of 25. Simplify. 4 times 5, square root of 25 is 5, times 4 is 20. And I'm done. Let's try again. I'm going to multiply this one by the square root of 3 over the square root of 3. And that gives me the square root of 2 times 3. I'm showing a little more work this time. Over 2 times 3 times 3. Which is the square root of 6. Over 2 square roots of 9. Which equals the square root of 6. Over square root of 9 is 3. 3 times 2 is 6. All right. A few practice problems. I'm going to work through these at a decent pace, and you're just going to have to ask questions as you get to something you don't understand. Okay, 3 square root of 12 times the square root of 6. We learned a rule that I can do 12 times 6. which is 3 square roots of 72. 72 breaks up into 9 times 8 doesn't work. I think there's a 16. Nope. 4, 36. 72 is the same as 2 times 36. So I can take that 36, take the square root of it, which is 6. 6 times 3 is 18 square roots of 2. Okay, square root of 6 times the square root of 6. Pretty simple. On this next one, we learned that that's multiplication. So here I'm multiplying two radicals. So I can say -4, and there's a -1. That's my coefficients. And the radicands are 15 times 3. So the coefficients give me +4. The radicand is 45. Oops. $45 breaks up into 9 times 5. Square root of 9 is 3. 3 times 4 is 12. All right, 5 square roots of 10. Square root of 50, which 50 is the same as 2 times 25. Square root of 5 is 5. Okay, 2 more slides. Okay, remember, if I have common radicals, I can do the subtraction of the coefficients. 3 minus 4 is -1. Square root of 6. Square root of 6 can't be simplified any further. Here I don't have the same coefficients, but I can get the same coefficients. 24 is the same as 4 times 6. I can take the square root of 4. So I have 2 square roots of 6 plus 2 square roots of 6. This radical simplifies. The square root of 4 is 2. 2 times 2 is 4. Excuse me. Let's go back to that. 24 breaks up into 4 times 6. Square root of 4 is 2. 2 times 2 is 4. So my final answer here is 6 square roots of 6. All right. Next, square root of 12 breaks up into 4 times 3. The square root of 4 is 2, so I get -2 square roots of 3 plus 3 square roots of 3. When my radicals match, I can just add the coefficients, and I get 1 square root of 3. And no, you do not have to write that 1 down. Okay, last one on this page, and there's one more slide after this. I need a common radical to add. So 54 breaks up into 9 times 6. The square root of 9 is 3. So I have 2 square roots of 6 plus the square root of 9 is 3. 3 times 3 is 9. 9 square roots of 6. Now that I have matching radicals, I can add the coefficients. 11 square roots of 6. Last page of practice problems. Here we're going to rationalize. So this first one I'm going to multiply, and I always just pick what radicals on the bottom. I know I can simplify the square root of 20, but I'm not going to yet. 15 times 20 is 300. So I have the square root of 300 over 5 times 20. Here, square root of 20 times the square root of 20 is the square root of 400. hold on. Square root of 400 is actually 20. So 5 times 20 is 100. And I can break this up into 3 times 100 equals 10 square roots of 3 over 100. Simplify. Square root of 3 over 10. Alright, next one. 27 over the square root of 27. Whoops, sorry. That gives me the square root of 6 times 27. Oh, I did it again. Over 27. 6 times 27 is 162. Let's see what 162. 162, make a list down here. Let's see, 9 times 18 doesn't help. 9 times 3. Let's see, sorry, 9 times 18, I'm going perfect squares. Let's see if I can divide by 16. 162 divide by 16. Nope. 162 divide by, so I checked, I'm checking the 3's. I checked the 4's, which is, I divided it by 16. I checked the 5, divided it by 25. Let's check 6. 162 divide by 36. Doesn't work. Check 7, which is 49. Nope. Check 8, which is 64. Nope. Check 9, which is 81. It worked. Okay, so you can erase all that. 162 is the same as 81 times 2. Who knew, right? Square root of 81 is 9. And I can simplify 9 and 27, dividing both sides by 3. Actually by 9. 9 goes into 9 1. 9 goes into 27 3 times. 2 square roots of 3. Phew. Okay, this last one, just showing you that when both things are underneath the radical, you can go like this. And simplify this way. Or you can actually do 45 divided by 9, which is the square root of 5. Okay, that's the last slide. Good work. You have work to do tomorrow in your book.